Okay, so I'm gonna start, guys. So good afternoon, everybody. So let me tell you what I did last time and what I'm gonna do today. So last time I told you our microcontroller, there is some hardware circuit inside the microcontroller. It is called timer or general purpose timer system. Is that okay? That's what I told you last time. Also, I made it very easy. I told you last time, I can use the timer system to do one of two things. Either to generate a square wave efficiently, and you will understand today exactly what I mean by efficiently. So, and that's what we call output compare. So here, I can use the timer system to generate a square wave, or I can use the timer system to measure time. For example, I want to measure the time from here to here, okay? That's what I explained last time. And also, I told you here how for our timer system, in the timer system, there is a counter, okay? You can tell from the English name, this counter is actually counting, okay? And this counter actually needs a clock to count, okay? This is a hardware counter. And for every period, the counter is going to be incremented by 1, okay? And I told you how this counter is going to help me to make output compare and input capture. In other words, how this counter is going to help me to measure time in input capture or to generate signal for output compare. Is that okay? So what I told you, how this can happen, for example, as we are going to do in the programs, if this signal of this clock is 1K hertz, okay, that means the period here is 1 millisecond. Is that okay? That means the count is incremented every 1 millisecond, okay? So, and this is the main idea. So all what I need to know, how many counts the counter counted from here to here. So I need number of counts. So if you can know that the timer, for example, the count here was 70 and the count here was 120. Okay, so this is the count here in the counter. That means from here to here, the counter counted 50 counts. Okay, and if you know this, how can we measure time? I am going to measure time in number of counts. Okay, and if you can know the number of counts, it's easy to convert to time. Why? Because every count, for sure, if we select 1K hertz clock here, every count is going to take 1 millisecond. You got what I'm saying? So that means from here to here is going to be 50 milliseconds. Okay, this is how we can do it. Same thing also when you generate a signal. So if I want to generate a signal, so that from here to here is going to be 50 milliseconds. So that means I need to toggle the pin. I need to toggle the pin every 50 counts. Is that okay? Also, I give you some application last time. Why we need to sometimes we need to generate a square wave. Why sometimes we need to measure time. Also, I told you you can ask the timer to count. You can ask the counter to count up counting. Okay, so this is something programming you can program. In case of up counting, as you see here, the counter is going to count from 0 until a certain value. This value is stored in a register. We call it ARR, or auto reload value, ARR. Okay, for example, this is a register. So if I put here 1000 in ARR, so it's going to count from 0 until 1000, and then it's going to come to 0 again, to 1000, 0 again, 1000, and so on. This is how it works. Okay, ARR is a register. Also, you have to keep in mind our counter is actually 16 bits. That means the maximum value you can put here is actually 535, which is 11111. Okay, that means when you select ARR, you can select any value as long it's okay, as long as it is less than or equal 535. It cannot be more than that. You understand what I'm saying? So ARR cannot, because the counter cannot count more than that. This is the maximum for the count. Okay, so So as you see here, this is, you can select up counting if you want. Also, we have down counting. As you see, here is a difference in down counting. You are going to start from ARR, it's going to decrement until it is 0, and then go to ARR again, decrement, and so on. So this is how the hardware it works. Okay. Also, there is another mode, we call it center aligned counting. So what happens here, again, this is something programming. You can program it. You can ask the counter to count using any one of these modes, okay? And that's what you're going to see in the programs today. So also, as you see here, you are going to count up until ARR, and then down until 0, and so on. You keep doing it this way, okay? What I told you guys, either input capture or output compare, there should be an external pin, that's for sure. Because in case of output compare, this is where I have to generate the square wave, okay? For input capture, this is where the input signal is going to come to measure the time, okay? So in both cases, there is a pin. Also, here, how I explain how it works. In case of output compare, this is how it works in output compare, okay? So what's going to happen here, guys? We are going to compare the count. This is the count here, okay? I'm going to compare the count to a certain value stored in a register CCR. Again, say again. So here we have a register, we call it CCR. So you can put some value here, for example, 500, for example, okay? Once this value is equal to CCR, two things are going to happen. So for example, let's look something here. For example, assume ARR here is 1,000. And then I'm going to put here in CCR, I'm going to put 500. So what's going to happen? What this means? It means when every time, this is CNT. CNT means this is the register for the counter. This is the count. Every time the count is equal to CCR at this moment here, two things are going to happen. Two things in case of output compare. Number one, interrupt is triggered. So there is interrupt here is triggered. Number two, action is going to be taken on the bin action. What do you mean by action? Yeah, so actually this is something also you can program. So for example, here we have several actions as I'm going to explain details today. For example, action can be make the bin high, as you see here. It can be make the bin low. It can be toggle, okay? It can be toggle. For example, if I select toggle, that means here the bin is going to toggle at this moment. So it's going to come here, toggle, and so on, okay? So as you will see, so there are some actions you can select out of this list of actions you can select. So this is output compare. So let me say again, what is output compare? Output compare means every time the count is equal to CCR, two things are going to happen. Interrupt is triggered. Number two, action is going to be taken on the pin, okay? So actually we have another source of interrupts. Listen to me. So we have interrupt coming from output compare here at this moment. Also, every time the timer it changes from ARR to 0, also interrupt is triggered here from the timer. Let me say it again. What I'm saying, this is another source of interrupt. So interrupt can come from the timer at overflow to tell you there is overflow. Or another interrupt can come from the output compare. Okay, when CCR equal to the count at this moment here. Is that okay? How can you use them? Okay, I'm going to explain to you how can you use them. But for now, you should understand interrupt can happen because of overflow. Also, interrupt can happen because CCR is equal to CNT. Is that okay? For input capture, yeah, that's what I'm explaining here. For input capture, what happens is that in input capture, what happens, we have external bin. Every time there is an event, a certain event, and also this is something you can program. You can program what do you want to capture. You want to capture only rising, falling, whatever, okay? So every time there is an event here on the pin, two things are going to happen in input capture. Okay, number one, interrupt is triggered. Number two, the value of the count, the value of the current count is stored in CCR. Okay. So in case of output compare, CCR, we write to CCR. When you write to CCR, you say, okay, I want to toggle the signal, or I want to toggle the pin when the counter is equal to CCR. However, in case of input capture, you are going to read CCR. You're not going to write to CCR, because actually here CCR is going to store. I think I have a very nice slide here. Yeah. So for example, yeah, I have very good slide here. So what happens here, guys? If I want to capture only rising, so what happens when rising comes here? Okay. So at this moment here, okay, the count was 30. So 30 is going to go to CCR. CCR, you are going to store 30, and you are going to trigger interrupt. Interrupt is triggered. Is that okay? Inside, so, and also in the second one here, another same thing here. So every time there is an event, two things are going to happen. Interrupt, and this one is going to go to CCR. Okay, so actually, as I told you, if I want to count the time from here to here, all what I need to know what was the count here, what was the count here, and then I can do the calculation to count to calculate the time from here to here. Okay, so for sure I need interrupt in this case. Why? Because here at this moment when there is interrupt, you have to take CCR, you have to store it somewhere. Otherwise, if you don't do that, when the second one comes, it's going to override CCR. You understand what I'm saying? So when the first event comes, okay, so the count, we call it timestamp, or count is stored in CCR. When you go to the subroutine, you have to empty CCR. You have to take this value, store it somewhere. Otherwise, the second one, when it comes, is going to override CCR. Okay. Anyway, so now. That's all what we have. So now what I'm gonna focus, what I'm gonna do right now, number one, I'm gonna talk about programming. How can we program it? And regarding programming, it's very easy. You know what we're gonna do? Exactly similar to what we did before. Number one, we have a number of registers. You have to write some numbers in the register to do initialization. That's very easy. That's what we did before. Okay, but we have too many registers here, but that's okay. But all what you have to do, you need to learn how. I'm going to tell you, we have one bit here. If you put one, something happens. If you put zero, something else you have. So this is initial. This is the first part. The second part is interrupts. And already you know how can we use interrupts. You got what I'm saying? That's all what we're going to do right now. Anyway, so first of all, I want to tell you, our processor does not have only one timer. Actually, we have 3 timers. Separate timers. So they are separate. They are independent. You got what I'm saying? That's good. So we have 3 timers. Okay? You understand what I'm saying? One timer, we call it timer 2. Timer 2. We have timer 22. We have timer 21. This is the 3 different timers we have. Again, I'm gonna say it again. They are independent. You got what I'm saying? So they are separate, independent. Okay? So we have 3 timers. Okay, guys? You can program any one of them. They are different. So they are different hardware. Okay. Not only that, this timer 2 actually has 4 channels. Timer 2 has actually 2 channels. Timer 21 has 2 channels. What this means? When you tell me a timer has 2 channels, or timer, number one, I made it very clear. We have 3 timers, they are separate. They separate hardware, programming separate. There is no link between them. Very, very clear, okay? Every timer, one timer, we have 4 channels. What this means? I'm gonna tell you what this means. The other 2 timers, every one of them has 2 channels. Okay, what this means? I'm gonna tell you what this. What it means is that we have one counter. And actually we have, for example, in one timer, we have 4 channels. 4 channels. Every channel has a pin. So this is a pin, this is a pin, this is a pin, this is a pin. Is that okay? You can program this is channels, all of them output compare or input capture. You got what I'm saying? So actually, so what I'm saying here, this timer has four channel. Every channel has its every channel has interrupts, its own interrupts. Every channel has a pin. Okay, So that means I can use this pin input capture, output compare, whatever you can program it. So they are separate in everything except one thing. So they are separate in the initialization. You will see right now, every channel has its own bits for initialization. Okay? They are separate in the interrupts as well. Every one of them has its own interrupt, but there is only one thing that's common between all of them, the counter. So all of them have only one counter. You got what I'm saying? Okay. So how this one can be useful? For sure, this is going to be very useful in a case like this one. If I want to measure the time from here to here. So what I can do, this one can input to one pin. This one has to input to another pin for the same counter. For synchronization. You got what I'm saying? Because I want to count the time from here to here. If you use if you use a different counter, it's not gonna work. You got what I'm saying? Because you are gonna have a synchronization issue, right? So what happens here, it's gonna be for the same counter. Anyway, so again, what I'm saying now, guys, is that we have, I'm gonna say it again. Number one, we have 3 timers. Okay, they are completely separate. They have separate hardware, separate, everything is separate. Okay, separate registers, as you will see right now. Number 2, for every timer, one timer we have 4 channels, one timer we have 2 channels, the other one we have also 2 channels. Okay, again, this is a channel, you can use them separately. So this one can be input capture, output compare, input capture, it's up to you. They are completely separate in the initialization. So every channel here has its own registers for initialization. Also, every channel has its own interrupt. So they are separate in everything except one thing. They share the same counter. Is that okay, guys? Okay. So that's what I'm saying here. So what I'm saying here, guys, we have 3 timers. Every timer has its channels. Okay, that means, listen to me. That means, for example, this one has 4 channels. Every channel has its own CCR. Every channel has its own CCR. That's true. However, for ARR, because this is related to the counter, so it's going to be only one for all of them. You got what I'm saying? So it's going to be clear now. So now there is another question I want to answer. You made it very clear for us. Okay, number 1, we are going to use the timer for input capture or output compare. Is that okay? And I made it very clear. In both cases, we need a pin. Either a pin to generate a signal or a pin to receive the input. Is that okay? So now the question, where is the pin? So now you told us, listen to me. You told us we have 4 here, 4 channels. We have 2 here, we have 2 here. So total, I have 8. Yes, that's true. So I need 8 pins. That's true. You need 8 pins. Is that okay? So where are these pins? Okay, I'm gonna tell you where. Okay. So what? So actually, there is something we call it as we did in chapter 3. If you have an external pin, you need to configure it. You need to configure the pin, input or output. Do you remember? So that's what we did in chapter 3. So I'm going to choose the code here. That's what we did before. Yeah. So what we did before, if you want to configure a pin, input or output, what did we do? Number 1, we have to do this one. Okay, that's what we did in chapter 3. And then you have to select here input or output. Okay. And then you remember, no, select push pull and so on. Okay. So actually here, look at this one. This register, mode, the mode register. That's what we did in chapter 3. But the difference is, listen to me, the difference is, I told you in chapter 3, if you put 0, 0 for a certain pin, you are going to configure the pin input. If you put 0, 1, you are going to configure the pin output. And that's what we did in chapter 3. So in chapter 3, what we did, either you configure the pin input or output, 3 and 4, right? Actually, there is another thing. You can also configure it as alternate function. And that's what we're going to do right now. So again, every pin, you can configure it input, output, and that's what we did before. Now because I'm not gonna use it as input or output, I'm gonna use it for the timer. In this case, I have to program it. I have to select it what we call alternate function. Okay. So in this case, when you do the initialization, this time you have to do 1 0. You should not do this one. You should not do this one. So when I do 1 0, that means this pin is going to be alternate function, not input, not output. But what do you mean by alternate function? I'm going to tell you what I mean. What I mean by alternate function is that this pin, there are some systems inside here, different systems like analog to digital, SPI, different systems. Okay. Alternate function means I want to connect this pin to this one or this one or this one or this one or timer as well, or this one. That's the meaning of alternate function. So now, the meaning of alternate function that this pin you want to connect it to one of the system we have. Okay. So if you see the what I'm doing here, guys, is if you P is these pins are here. P is 0. P is 0. Okay. These are the different alternate functions for P is 0. Okay. So for example, for sure, this one is for serial communication. Okay, we're not going to do serial communication. So let's focus on the timer. So if I program PE0, okay, to act to alternate function number 2, this actually is going to be timer 2 channel number 1. Or you can ask this one to be connected to the serial communication or to the comparator and so on. So here, this all the alternate functions for every pin. So as you see here, guys, every pin can be connected to any of the systems you have. Is that okay? So again, if I want to use one channel, okay, so you have to write a code to connect a pin to this channel. Okay. And by the way, as you see here, for example, this is timer 1, channel 1. So I can connect channel 1 of timer 1 to BE0. Okay. If you look again here, somewhere also, yeah, for example, here, yeah, look here, guys. This is timer 2, channel 1 again here. You got what I'm saying? So that means a channel 1, you can connect it to BE0 or you can connect it to BE8. You got what I'm saying? You need to do initialization to do that. Okay. So what I want to say, you have multiple options for every channel. You got what I'm saying? I think if you look again, maybe you can find it also somewhere else. I'm not sure, but I just want to tell you what I want to tell you is for example here, for any channel, sometimes you can have more than one option. So here, if I want to use a channel 1 of timer 2, as you see here, guys, in this case, I'm gonna program for BE0, I'm gonna program it to alternate function 2. But for here, for BE8, so I'm gonna select alternate function number 5. Okay, I'm gonna tell you for sure how can you do that. Okay. Anyways, this is what I want to say. Okay, so again, the conclusion, guys, is that we have 3 timers. Every timer has, they are separate for sure. Every timer has more than one channel. Okay, every channel has its own registers for initialization. Every channel has its own interrupt. However, they share the same counter. Okay, so I'm going to give you more details now. So let's start with. So in this section, I'm going to talk about programming. How can you program it? As I told you, very simple. In order to program it, similar to what we did before, we have to do two things. Number one, initialization. Some registers, you have to put 0, 1, 0, 1 on some registers to do initialization. This is number 1. Number 2, you need to know how can you use the interrupts. And we already used it before. It's going to be exactly the same thing as we did before. Okay? So nothing is new. Anyway, so let's start with here. As I told you before, the counter has a clock. The counter has a clock. Can you program this clock? Can you select what clock you have here? The answer is yes. So for example, we have a register, we call it prescaler. Okay, guys. So what we can do here, and we have the input clock here. For example, if this is the system clock, it's going to be 2.09, something like that, megahertz. Okay. So what you can do is that the value you are going to put it here, you are going to divide. So as you see here, guys, the system clock, I can divide it by this value in order to get the clock of the timer. So the answer, or what I want to say is that you can somehow control the clock of the timer by programming prescaler. Okay, guys. So by selecting a certain value for the prescaler, I can change the clock of the timer. Okay. So this actually, I can say this clock actually is gonna express the resolution of counting. It's gonna be the resolution of counting. How fast counting can be done. So for example, if I select here 1 millisecond, that means we're gonna count one count every 1 millisecond. Is that okay? So you can change this time for sure. Okay. So the first thing you have to do, guys, is you need to initialize the clock of the counter. How can you initialize the clock of the counter? Just by writing to the prescaler. Okay. One more thing, as I told you guys here, we have several channels. Every channel has its own CCR. So we have CCR1, CCR2, CCR3, CCR4. If you have 4 channels, so every channel has its own CCR. That's okay. However, all of them share the same counter. That's why we have only one CNT. So CNT is a register. This one is going to give you what is the current count. All of them have the same one ARR because this is for the register. For example, let me give you just to understand better what I want to say. If I come here, look here, guys. That's what I said. Look here. Every time, if I use this way, again, there are different ways to use the timer. If I use this way, there is a toggle here, there is a toggle here. So every time CCR equal to CNT, there is a toggle. Okay. I can add something here to better understand what I want to say. Look here. Here, I can say this is CCR1, and this can be channel 1. I can have another one for CCR2. And in this case, maybe I'm going to have a different signal somehow here. So toggle here, toggle here. So I can have another one for CCR3, CCR4. Okay, but all of them are using the same counter. You got what I'm saying? So, but every channel has its own CCR, it has its own pin, it has its own signal. Okay. Okay. So now, tell me, you told me all what I have to do, guys, in order to program the counter. I need number one to tell me where is the prescale, and using the prescale, this is just a register. I can control the frequency of the timer. This is number one. Number two, you have to tell me what is ARR, where I can find ARR. Just again, this is a register. It's gonna count until ARR, and so on. Okay, this is number two. You need to tell me. Also, you told me there is a register, we call it CNT. Okay, so this register is going to give you the current count. Okay, so I'm going to tell you about it as well. And also we have CCR. Okay, for each one. So this is exactly how can you do it. Look here, guys. If we talk about timer 2, you can see timer 2 and then CNT. So this one is going to give you the current count in timer 2. Okay, timer 21. So this is CNT for timer 21. This is for timer 22. Is that okay? So this is just a register, 24 bits. This one is going to give you the current count. So this value is increasing for sure. Okay. Also, every timer has ARR, as you see here. For timer 2, we have ARR. Is that okay? Every timer has prescaler here. Easy, right? Also, everyone has its own CCR. Okay. So, but actually, as you see here, timer 2, because we have 4 different CCR. As you see here, we have 4. For timer 21, we have 2. For timer 22, we have 2. Okay? Great. So registers. All of this just a register. And the way you can do it, just write. As you see here, just a register, you can write whatever you want to write. For example, in prescale, I'm going to write 200. In ARR, I'm going to write 200, 300, whatever. So I just want to show you here in this slide, how can you read or write them? Just write whatever. It's just a register. You can write to it or read to it. Very simple. Okay? Any questions? Okay. Now, let's do another thing here for initialization. Remember, before we use any general input-output port, I told you have to enable the clock for this part. You got what I'm saying? We did it in several places. This is how they designed the microcontroller. Any system you want to use, I'm not gonna give a clock. I'm not gonna enable this part of the microcontroller unless you do it in order to save power. This is how can we save power. If you don't use the timer, why I have to send the clock to this part of the microcontroller? That's exactly the same thing we're gonna do right now. So if you wanna use the timer system, so you have to enable the system itself. Okay, this has nothing to do with the counter. It's a different. Okay, as I told you before, if you want to use ports, you need to enable the clock of the ports. Okay, so even we use the same register. I think we used to before the same register. Okay, anyway, so here what I'm saying, if you want to use timer 2, so actually in this register you have to make sure to put 1 here in order to enable the circuit of timer 2. Okay, same thing for 21. So in this bit in this register here. Okay, you have to put 1. If you want to use 22, you have to put 1 here in this one. Any questions? Yeah, and this you do it using OR. Any questions? It's very easy, right? Other thing here, we have another enable, but this time this enable is different from what I explained to you before. This enable for counting. Do you want as a counter count or stop counting? You got what I'm saying? But this one, in order to if you want as the whole, it's like turn on and off for the whole system. You got what I'm saying? Anyway, so there is another enable here, guys. In this register, we have a register, we call it CR1. As you see here, CR1. And by the way, we have 3 of them. Okay, we have timer 2 CR1, we have timer 22 CR1, we have timer 21 CR1. Okay, so we have every time it has its own CR1. All what you have to do if you want to enable counting, if you want the timer to count, you have to make sure put 1 here in this bit. That's it. Very simple. Okay, it's also something you have to do in the initialization. The other thing, as I explained before, in interrupts. If there are interrupts, I need to know the handler. Okay, what is the handler? So if you look here, guys, we have here. We have three interrupts here. 1 for timer 2, 1 for timer 21, 1 for timer 22. Okay, and this is a number. You remember we used this number before. Okay, in priority, in enable, we use this number. Okay, so if you want to, in case of timer 2, this is the handler. Okay, we did it in chapter 4, right? But in chapter 4 we used this one external. Okay. And we use the systematic. This time we are using this one. Okay, that's what I'm saying. Nothing is new. I'm going to use interrupts. I'm going to configure some registers to use the timer. That's it. Okay. But wait a second. Here you are telling us there is only 1 handler for timer 2. Although in timer 2, we have 4 different sources of interrupts, 1 handler. Why in timer 2 we have four different sources of interrupts? As I told you, because we have 4 channels. Every channel can trigger interrupt in case of output compare or input capture. This is number 1. So we have 4 channels. Every channel can trigger interrupt for output compare or input capture. This is 4, right? Also, we have another interrupt can come from the timer itself for overflows. When the timer overflow. Is that okay? So all of them, yes, that's true. So we have 4 sources of interrupts in timer 2. Timer 21, we have 3 sources of interrupts. This one we have 3 sources of interrupts because they have only 2 channels. Okay. Yes, they share the same handler. They share the same handler. That means when you go to this handler, you need to check. If this interrupt coming from channel 1, channel 2, or channel 3, or coming from overflow. Yes, there is some bits you can check. Okay. By the way, this is not something new. This is exactly what we did before. That's not something. This is exactly the same thing we did before. You remember when you did this one. So here in this one, here we actually have this one. It's the same handler for how many interrupts? From 4 to 15. So more than 12, I think, or 11 interrupts are going to come to the same handler. You understand what I'm saying? So yes, it's the same subroutine. Okay. Different interrupts can trigger them, and very easy. All what you have to do, just inside the subroutine, you have to check if interrupt is triggered because of channel 0, sorry, channel 1, channel 2, channel 3, or because of overflow. Okay, yes, we're gonna do that. Also, for any interrupt, similar to what I did before, for any interrupt, as I told you, there is an enable bit. There is an enable bit. In order to enable or disable interrupts, that's exactly the same thing here. So we have a register. This register is called DIER. Actually, we have 3 of them. So we have one here for timer 2. We have for timer for 21 and 22. Okay, guys. So as you see here, guys, in this picture, as you see here, we have 1 bit to enable or disable interrupts for the channels, and also for we call it update interrupts. So this one is for overflows, when the timer overflows. Is that okay? By the way, if you talk about 21 or 22, so we don't have these 2. Okay, we only have channel 1 and 2. We don't have these 2. Make sense? Okay, so here we have these 4 for channel 2. Okay? Again, this is exactly what we did before. Every interrupt, so there is 1 bit. You have to enable or disable interrupts of this one. Also, similar to what we did before, you have to enable the interrupts of NVIC. Remember, that's exactly what we did before. So all what you have to do, you have to put the interrupt number here. Here, this is where, that's exactly what we did before. Nothing is new. This is where we have to use these numbers. Okay? Any questions? Okay. What else you have here? We have what we call the flag bit. To remember when I explained interrupts, I told you, if you want to interrupt, you have to raise your hand. Okay? Yes, that's exactly. So there is what we call a flag bit. So the hardware is going to put 1 here to request interrupt, and the software, it has to clear it. You have to put 0 here. Is that okay? So where are the flag bits here? All the flags bits are in a register. We call it a status register, as you see here. Okay. So, and again, we have 3 of them. For every timer, we have 1 of them. Okay. So for timer 2, as you see here, this bit for overflows. And after that, we have 4 bits, 1 bit for every channel. Okay. So again, if there is an interrupt coming from channel 1 has to put, hardware is going to put 1 here. Software is going to put 0 here. Software is going to put 0. Is that okay? And I told you, it's very serious. If you forget it, you are going to have continuous interrupts. Any questions? Okay. I already explained this one, guys. For any pin, if you want to use any pin, you have to do the initialization we did before. Okay. For any pin, it's the same initialization we did before. However, the only difference is that what we did before, we selected either 00 for input, or we made 01 for output. But this time you have to make sure you have to put 10. So here in the mode register, you have to put 10 to configure it alternate function. So you are telling the hardware this pin is gonna be connected to alternate function. Is that okay? Any question? So this is similar to what we did before. Okay, but something is missing. You have just told us alternate function. It doesn't mean only one thing. For example, for this one, alternate function can mean several things, right? So to which one it is connected? You understand what I'm saying? So actually, all of these are alternate function. So here for this pin, if I connect alternate function 1 is going to be connected to this device. If it's connected to alternate function 2, is going to be this device. It's going to connect this one to alternate function number 4, and so on. So how the hardware, because the same pin can be connected to several systems. So which one? Okay. Actually, here we don't tell. Here we don't tell. Here you just say I'm going to use this pin alternate function. That's it. There is another register where you can tell. You can say yes, I want this one to be connected to this one, or this one, or this one, or this one, and so on. Okay, guys. How? I'm going to tell you. Very simple. All what you have to do, guys. There is a register. For if I wanna connect this one to alternate function 0, which is nothing, so you have to put 0. Here, alternate function 1, you have to put 1, 2, 3, 4, and so on. Okay, so you have to tell me there is another register, as you will see right now. This register, you are gonna tell you wanna connect this pin to which alternate. So where are these ones? As you see here, guys. For example, in register A, we have this register AFR0, and also we have AFR1. Okay, so 2 register. Why we need 2 register? Because we have 16 pins. So one register AFR0 is gonna be used for pin from 0 until 7, and AFR1 are, I think that's a mistake. I'm sorry. This one should be AFR1. I'm sorry. Okay. So the other one can be used to program pins from 8 to 15. You got what I'm saying? So now I have two registers. Okay. One register is going to be used for the pins from 0 to 7, 8 pins, and the other 8 pins are here. Is that okay? For example, if I want to use pin 0, from pin 0 until number 7, this is one register. From 8 until 15, this is another register. Is that okay? As you see here, for every register, we have 4 bits. For every pin, 4 bits. 4 bits. Yes. In these 4 bits, you have to tell me you want to connect the pin to which alternate function. For example, if I want to connect here BA0, I want to connect it to this alternate function. So I have to put number 1. If I want to connect it here, I have to put number 2. You understand what I'm saying? So I have to this number, the number you see here, if I want to connect it to this one, so I have in the 4 bits, I have to put number 7 here. You got what I'm saying? Same thing for any other pins. Okay, guys. So that's exactly what you have to do. So here you can use AND, you can use or and AND, so that if I want to this pin, this one here for BA0, if you use this one for port A, so here if I put here number 1, so actually I'm gonna connect BA0 to alternate function number 1, which is this one. For sure, if you want to use the timer, so you have to use this one. Okay, so again, all what you have to do, have to put the number. Which number? Okay, guys, don't be confused. I'm gonna say it again. Don't be confused. Number 1, here I'm gonna tell the hardware I'm gonna connect the pin to an alternate function, but I'm not gonna tell which system exactly. Okay, it just is gonna be alternate function, because every pin, as you see here, every pin can be connected to different systems. Okay, serial communication, analog to digital, whatever it is. Okay, this is here you are gonna tell here in this region. Here it's another register, AFR, alternate function register. Here every pin has 4 bits. Here you can tell here I'm gonna connect this pin to alternate function. Which number? So it's a number here. Okay, it's a number here. Which number? Any questions? Okay. What else do you have? There are too many registers. Yeah, there are many, but they are easy. Okay, so once you figure it out, it's gonna be easy. Just some register, you put some values. Okay. One more thing, guys. If in case of output compare, if I want to use output compare, I told you in output compare, every time CCR equals CNT, every time the counter is equal to CCR, 2 things are gonna happen. That's what I said. Number 1, interrupt is triggered. Number 2, action has to be taken on the pin. Is that okay? Okay, now, what action? What do you mean by action? Yeah, this is something you can program. So for example, you can see here, if I select this one, that means no change. Yeah, sometimes you need something like that, no change. What do you mean by no change? It means if the pin is 0, keep it 0. If it is 1, keep it 1. Okay. Other thing here, high, pull it high. So that means if I select this action, that means when CCR equal to CNT, this please make this pin high. This is the action. What action you want to take on the pin? Okay. We have another one, make it low. Okay. So when CCR is equal to CNT, make this pin low. Okay. The other one, toggle. So every time CCR equal to CNT, toggle the pin. Okay. Also, we have another thing here for pulse width modulation. Anyway, I'm going to talk about them in details, but let me now only focus on programming. So again, for now, we have different modes for output compare, or I'm going to say it in a different way. We have different action you want to take on the pin. So how can we program it? Very simple. As you see here, guys, every channel, because this is going to be different from one channel to another, right? So one channel, you can say this is the action for one channel, this is a different channel, and so on. Okay. So what's gonna happen, guys, is that as you see here, we have 2 registers, CCMR1, CCMR2. Okay. In this register, you can select the mode for channel 1 and channel 2. Bit number 4 to 6, 12. So here we have 3 bits for channel 1 and this one for channel 2. For channel 3 and 4, we have 3 bits here in this register. We have another 3 bits here for every channel. For sure, I don't need to keep saying if in case of timer 22 or timer 21, we don't have channel 3 or 4. So we're going to only use this one. Okay. Anyway, so as you see here, guys, every channel has 3 bits. 3 bits. These are the location of the bits in this register. These are the location of the bits in this register. Is that okay? All what you have to do in this bits, just put value of this one to ask output compare to do this action or that action and so on. Any questions? Don't be confused. I'm gonna give you a big program so you will see how I can use it. But again, if I want to do something very simple like toggle. If I use toggle, okay, you can generate a signal like this one. Okay, for example, this is something too simple. Let me see where, yeah, here. So let me clear this one to understand what I'm saying. So here, the action is toggle. That means every time CCR equal to the count toggle. Okay, so here there is a toggle. Here there is another toggle here. There is another toggle here. This another toggle here. This is how can you generate this signal if you do. And this is the first program I'm going to teach. This is the first program I'm going to teach. Okay. Any questions? Okay. What other registers do you have? What else do you need? Yeah, something is missing in case of input in case of input capture. Okay. In case of input capture, what do you want to capture? You want to capture, as I told you before, if you have a signal like this one, and I want to calculate the time from here to here. In this case, it is enough to capture only rising, right? Or falling, but falling is going to be here from here to here. Okay. However, we have other options. You can capture rising and falling as well. So what do you want to capture? You want to capture only rising, only falling, or both? Okay. So as you see here, guys, what happens here in this register, for every channel we have 2 bits. They are not next to each other. This is how they made it. So for example, for channel 1, here we have bit 1 and bit 3. For channel 2 in this register, okay? Every timer has a register like this one, okay? This is for channel 2, this is for channel 3, this is for channel 4, okay? All what you have to do is that if you want to capture only rising, just to put here in these 2 bits, put 0, 0. If you want to capture only falling, just in these 2 bits, put 0, 1. If you want to capture both, only in these 2 bits, put 1, 1. Easy, right? Any questions? Okay. What else I can do? Okay. Again, it's very easy, but I understand it's too many things. That's okay. Too many registers, too many things. But it's just easy. And when I show you a programs are going to put everything together, as you will see. Anyway. Also, we have something we call it enable register. Okay. Enable register. So this is not an enable for interrupts. It's like you can turn the channel on and off. Okay. So this is turn on and off for it's a channel. Do you want the channel to work or not? So if the channel is generating a score wave and you don't want a score wave anymore, okay, you can turn it off. You can turn the channel off using this bit. So here, as you see, every channel has 1 bit, as you see here. Every channel has 1 bit. Is that okay? So actually here 1 bit is you can enable or disable in every bit here. Okay. So 1 bit to enable. Again, this is not for interrupt. This is like you turn the channel itself on and off. Okay. Is that everything, or you have? This is the last thing I have. Last one. Okay. Yeah, there are too many, but that's okay. I told you before. For the timer, the timer can work this way. You can count up, or you can count down, as I said before, or up and down. So we have 3 different ways. So the way you can do it using this register, CRI1, every timer has 1 of this register. So this bit you can select the direction. So if you put here 0, that means I want to count up. If you put here 1, that means only up this way. Okay. So if you put here 1, so you are gonna do it only the decrement. Okay. There is no big difference, but I'm gonna give you some examples to understand it. We have 2 bits here to select what we call center aligned mode. Center aligned mode, this is the mode I told you, up, down, this way. Okay. Anyway, so here what I'm saying is that if you see, so if you want to count up, just put here 0. That's it. If you want to count down, just put here 1. Okay. If you want to count, if you this way, up, down, this way, increment, decrement, and so on, you have 2 bits here. Okay. So actually, for these 2 bits, we have 3 options. You can put 1 1 or 0 1 and 1. Or you have or 1 0. I'm sorry, I think there's a mistake. This is 1 0. Anyway, there is no big difference between them. So here, any value other than 0 0, you are gonna be counting up and down this way. But there is a small difference. What's the small difference? You want to trigger interrupts here, or only here, or in both. This is the only difference between them. It may not be a big deal, but this is the only difference. So if you put here, if you put in these 2 bits, if you put any value other than 0 0, so actually the timer is gonna work this way, but you can select different values when you want to trigger interrupt. Only here, or in both. It's not a big deal. Okay. Any questions? Again. Number 1, should understand what is timer and how can we use it. Okay. Or also we can use it to generate score wave or to measure time. Okay. This is number 1. Number 2, I accept is the way you are gonna program it. Very simple. Number 1, there are some registers. You need to initialize this register. That's it. For initialize, similar to what we did before. On top of that, sometimes you need interrupts. I'm going to show programs right now with interrupts. I'm going to show some programs I do need interrupts, without interrupts. I may not need interrupts, as you will see right now. So let's start with the first program here. In this first program, guys, I wanna generate a score wave this way. I want to square it with this way. From here to here, it is 1 second. From here to here, it is 1 second. Okay, and this one actually is connected to BB0. You remember BB0 has an LED. So by this way, you can do flashing, turn on, off. Okay, you will understand the beauty of timers now, because we did flashing in chapter 3. But when I did flashing in chapter 3, I took 100% of the time of the microcontroller, 100% in chapter 3. Now you will see the miracle or the great thing here. Okay, the great thing here is after initialization, I need 0 second from the microcontroller. The signal is going to be generated by the hardware after initialization. So I just need the processor to do the initialization. After initialization, thanks processor, I don't go and take care of the other things. I will take care of the flash. You understand what I'm saying? So you will see how this can be done. Okay. So number 1, if I go to, I'm going to show how I did the initialization quickly. But if you look here, BB0 here. In BB0, the only option you have is channel 3 of timer 2. Is that okay? I selected BB0 because the LED is connected to BB0. Okay. Again, you have all the programs. I tested them. I'm 100% I'm sure all these programs are working because I tested them. Okay. Anyway, so that means if I want to generate, if I want to output compare, for sure I want to generate a score wave here. If I want to generate a score wave, so you have to use output compare with BB0. That means you have to use the channel 3 of timer 2. That's the only option you have. Okay. So let's see how can you do it. Number one, I have to program the counter. Okay. So here I told you I'm going to select this prescale to be 2096. Why you selected this number? So that by selecting this number, guys, as I told you, we have here a counter. This counter, we have a clock this way. Okay. So I told you how can we generate this clock? It's going to be the input clock, which is 2.097 megahertz divided by prescale. Okay. So if I make prescale this way, so actually this one can be 1 kilohertz. If you just do the math, that's why I'm going to select the prescale to be 2096. Why? So that the timer is going to increment the count every 1 millisecond. So every one count means 1 millisecond. Every one count, that means 1 millisecond because I selected the frequency this way. Okay, guys, any questions? How can you do that? Very simple. So all what I did, if you see here, I'm going to jump a little bit here to the initialization. Here, all what you have to do is just here, when you call the timer, okay, you have to put the value here. I put it P because in here I'm getting in the main P is going to be actually, yeah, I'm going to send, I created a function anyway, but all what you have to do, this value, you have to put this value here anyway in this register. Very simple. Okay, so this is the first thing I have to do. Okay, the second thing I have to do is ARR. What is the value of ARR? Okay, I'm going to select ARR to be 999. Why? Because if you selected 999, what's going to happen is that you are going to count from 0 until 999. Okay, and then it's going to take one more clock for 0. Okay, to go to 0 again. So total is going to be 1000. That's why I selected 999. Okay, so what I want to tell you here, guys, is that if you look, okay, so this is the mode I'm going to use. So I'm going to use counting up. Okay, I'm going to use toggle. Okay, this is what I'm going to use. ARR, I'm going to put here in AR 999. Is that okay? If you do that, you can see the time from here to here is actually going to be 1 plus ARR times 1 over the clock, which is 1 millisecond. Make sense? Yes, because you have to count. We have to count from 0 until ARR, plus there is another one here to go up. So the total, you can see how much time is going to take from here. How much time? It's going to be 1 plus ARR time 1 over clock, which is 1 millisecond. Is that okay? Okay. Number 2. Okay, what about, so that means there is a toggle here, and there is a toggle here, there is a toggle here. That means this is the output frequency. This is the output signal I'm going to get. I'm going to get output signal this way. Okay. If you look at this signal, you can see what is the frequency of this signal. The frequency of this signal actually is going to be double this one, because if you flip here, flip here, so actually the time from here, the time from here is going to be, from here to here is going to be equal to this one equal to this one. So actually the frequency or the period is going to be double this value. Okay, double this value here. Makes sense? I'm going to tell you we already have the program. You can test it. I'm going to tell you something very interesting. I need someone to think with me. Okay, look here, guys. So what I'm saying, because I'm going to toggle here. Okay. So this is the output frequency. This one. So if I don't change ARR and I change CCR, so assume I'm going to change CCR. So CCR, I'm going to make it here, or I'm going to make it here. Any value less than 999. Any value less than 99. Okay. I told you about the restrictions. There are some restrictions. You should understand it. Otherwise, it's not going to work. Okay. The first restriction, ARR, it has to be less than or equal 65535, because 16-bit counter. This number 1. The second restriction, CCR has to be less than ARR. So if you put CCR greater than, and I did this one by mistake, by the way. So when I did the programs, I put CCR, for example, here, up here, and nothing happened because it never happened that CNT is equal to CCR. Never happened. So I got no signal. Anyway, so you have to make sure the CCR less than AR. I'm going to tell you something interesting now. Okay, think about it. If I change CCR, how this will change the output frequency or the output duty cycle? So for example, if I make it here, so actually there is a toggle here and toggle here and toggle here. Or if I make it here, I'm going to toggle here, we're going to toggle here, we're going to toggle here. So you will see now, regardless of the value of CCR, number 1, you're going to get the same frequency, you're going to get the same duty cycle, 50%. Okay. I'm going to tell you about other programs, but for other programs, you can change the duty cycle, you can change the frequency. But here, it's changing CCR. CCR has no impact other than you just shift. So instead, you are going to start from here. But you are going to get always, regardless of the value of CCR, 50% duty cycle, and also frequency is going to be the same. It's in this example, okay? For sure, if you want to change the frequency for some reason, you need to change ARR, okay? Anyway, and you already have the program. So when you run this program, you see flashing. Okay, try to change this CR and see. If you don't believe me, and see. Okay, change this CR and see if the frequency of flashing is going to change or not. Because actually, the time from here to here is going to here that this is same like this one. It's the same if I put CCR here. So this time from here, it's the same. You got what I'm saying? It's the same time. Anyway, so this is the first thing you have to do. So you have this program here, guys. Okay, so this is the code you have. What I did is I created a function. I call this function. This is the initialization for output compare for bin BB0. Okay, I created this function, and this function you can send three things to this function. You can send prescale, you can send CCR, you can also send ARR. Okay, three things to the function. Anyway, so this is a function. You can see in this function, the first part in the code is just initialization for the pin. And as I told you before, here you have to select alternate function. Also, here I have to tell BB0, please connect to which alternate function? Let me go back. Yeah, here. So here, yes, I want a BB0 to connect it with this one, which alternate function number 5. So here, as you will see, I'm gonna say here number 5. Okay, that's exactly what I did here. Okay, anyway, and now this is the rest of the function for initialization. I told you for the timer, you need to enable the timer. Okay. Then we have PCA. So this is for the prescale. This is for CCR. Look here, I'm going to use CCR 3 because I'm using channel 3. And this is for ARR. Okay. Number 2, what else I need to do here? What you need to do here, you have to say what mode you are going to use. In this case, because I'm going to use toggle. So every time CCR, so here in case of toggle, yeah, if you want to do toggle, you have to put this number 011. You have to put it in here. I'm using channel 3, so you have to put it here because you are using channel 3. Anyway, I don't want to spend much time to explain the initialization because it's just very easy. So here, yes. So here I'm gonna say I want a toggle. Okay, are you done? No, I'm not done yet. So still you need to do two things. You need to turn channel 3 on. This is this bit for to turn channel 3 on. Also, you have to enable counting for the timer. Is that okay? I'm not using interrupts. That's why I did not enable interrupts here. In this example, I don't need interrupts. In other programs, I'm going to use interrupts, but here I don't need interrupts. I'm not going to use interrupts. Is that okay? Okay. Now, in the main program, and this is the beauty. Now, in the main program, all what I'm going to do, just I'm going to call this function. I'm going to send you these values here. Okay. When you go home, you can just play in these numbers. Again, I selected this value so that every count is going to become 1 millisecond. And this is ARR, okay? And this one is CRR. You change the CCR, has no impact. But if you make CCR greater than 1,000, you are not going to have a flashing. You are not going to have a signal. So this is the beauty is here. What is the beauty? Beauty is that all what I need from you, microprocessor, is just to do the initialization. So the microprocessor is going to execute this one, execute this one, execute this function. That's it. That's it. After that, without interrupts, no interrupts, I'm going to take 0 time from you. This is the beauty. So now the processor is going to initialize the hardware. Once the hardware is initialized, the hardware is going to take care of everything after that. Once you do this initialization, you are going to have a signal this way. This signal is going to be generated forever until you turn it off. How can you turn it off? I told you there is, there is one bit here to turn the signal on and off. Okay, turn the channel off and off. That's it. Okay, this is a very simple program without interrupts. I can just use the timer to generate signals. This one. Any questions? Okay, so now also because I was playing, I love it. I was playing, so I changed the program instead of counting. By the way, you may be confused. So here, I did not write a code here for counting up or counting down. Okay. Sometimes that's okay. You know why? I'm going to tell you what. Because the reset state, the initial values. If I don't say you have to count up or down or whatever, automatically it's going to count up. You got what I'm saying? So I don't need to write instruction. But yeah. So here I didn't say anything So the initial state is counting up. So in this case, it was counting up. If you want to change it to count down, you have to write this command. I told you there is 1 bit for counting up or counting down. If you put 0, I guess 0 for up, 1 for down. Anyway, so for counting down, I did it and I got exactly the same signal. I got the same results. Everything was the same. Okay, makes sense? Everything was the same. Think about it. You will find everything toggle here, toggle here, toggle here. Frequency is the same. Duty cycle is the same. Everything is the same. Okay. Now, if I want to do center aligned, I told you there are 2 bits, as I explained to you before. These 2 bits, you can put anything other than 0, 0. Okay. So you can put 1, 0 or 1, 1. Here I decided to put 1, 1. Okay. So in this case, this is an interesting part. Okay. In this case, it's gonna go up, go down, up and down. Okay. Now it's gonna toggle here, toggle here, toggle here, toggle here. Okay. If you look at the frequency does not depend on CCR, similar to what I did before. The frequency only depends on ARR on the clock, right? However, what we did before is that the duty cycle was 50%. And even if you change CCR, no impact. When you change CCR, it's going to be the same duty cycle, right? Because if you toggle here, from here to here, or here to here, it's going to be the same time. So it's no change. Here, no. Here, because actually this is the time for high. This is the time for high. So the more I bring CCR up, so actually you are going to make it narrow. You understand what I'm saying? So now, yes, and you can write it when you go home. So now CCR has impact on the duty cycle, okay? Because every time here is going to be high from here to here. So but the frequency will be the same. You understand what I'm saying? So it's the same frequency, but actually, as I bring the CCR down, so actually the time here is going to increase. As bullet high, the time is going to be decreased. So I can change the duty cycle this way. What is the duty cycle? I'm going to tell you what is the duty cycle. Okay, very simple. Again, I have the total count from here to here. The total count from here to here is actually 2. The total count is actually 2 times 1 plus ARR. Okay. So how many counts we have from here to here? How many counts? Okay, very simple. Look here, guys. It's going to be this count plus this count, and they are symmetric. So it's going to be 2 times this count. Okay, how many times you are going to count here? It's going to be actually ARR minus CCR. So it's going to be actually 2 times ARR minus CCR. Okay. So actually, so here, the count from here to here is going to be 2 times ARR minus CCR. Okay. I'm going to divide it by the total count, which is from here until for the whole period. So in this case, you can see that the duty cycle is actually 1 minus CCR divided by ARR. Let me tell you conclusion. Very important conclusion. Number 1, if you want to use this mode, if you want to use it this way, number 1, I don't need interrupts. No interrupts. Right? Number 2, the frequency is going to depend only on ARR and the clock. Okay. Number 3, CCR can be used to change the duty cycle this way. 1 minus CCR divided by ARR. Is that okay? By this way, so I can change the duty cycle. Any questions? Okay. So now I'm gonna take it. I'm not gonna teach anything new. I already explained what we have. We have a timer. When it is equal, it's gonna trigger interrupt. We have action, whatever. That's what we have. What I'm explaining is this section. How can we use it? How we can use it? So I already explained one way how can we use it. So I already explained this program here. Okay. The second program I'm gonna teach is although this is not the main functionality of output compare. Listen to me. Output compare is used, as I told you, to generate signals. That's what I told you. Okay. However, you can also use output compare to generate periodic interrupts. Like system tech. You understand what I'm saying? So what I'm gonna do right now, I wanna generate it like system tech. Right? I wanna generate periodic interrupts. I don't want to generate a signal. I wanna have system tech. You understand what I'm saying? Periodic interrupts. Why this one can generate periodic interrupts? For sure it can. You know why? I'm gonna tell you why. Simply. That's exactly what I explained. So what I told you guys here is that here what I said, every time counter is equal to CCR, there is an interrupt is triggered here. So there is one interrupt here, one interrupt here, one interrupt here, one interrupt here. This is periodic interrupts. So here I'm gonna take one interrupt every this time. This is exactly periodic interrupts. You got what I'm saying? Now I don't care. I'm not gonna generate a signal. I don't care about the signal. I just want to get periodic interrupts. So all what I'm gonna do right now, listen to me. I'm gonna make a little modification in the program I taught right now. In this little modification, again, in the program I taught right now, I did not program interrupts because I didn't need interrupts. Now I need interrupts. So I'm gonna add a code. I'm gonna add a code for interrupts. Okay. So if I want to use this way, guys, so all what I'm gonna have one interrupt here, one interrupt here, one interrupt here. So the time between, or the time out in this case is gonna be this value. Time out. Is that okay? So it does not depend on CCR. For now, I'm gonna modify it more. Again, this is like a tool. The tool, you can use it in different ways. So now I'm gonna make it very simple. The time out does not depend on because if you put CCR here, from here to here is gonna be the same time. If you put here, from here to here is gonna be the same time. Okay. So actually, the time here, this is the time here, time out. So the time out depends only on ARR. I'm gonna modify the program right now, and I'm gonna make more flexible because it's not very flexible now. Now it does not depend on CCR. Okay, let's do this one. So I'm gonna modify the previous program by doing these things. So exactly same thing as I did before, but I'm gonna do some modification. Number one, I have to write the code for interrupts. So I have to enable interrupts, 1 bit, that's easy, 1 bit and in VIC, right? Number two, I have to write the handler, okay? For mode, I don't care, I'm not gonna select a toggle, so I can select no action for the mode. You remember if I go to the table here, because I'm not interested, I'm not interested to generate, I don't want, so I can say no action because there is no need to, I don't want to generate signal. I just want to trigger periodic interrupts. Okay, you can do that. The time out, the time out is going to be half the period, which as I told you, 1 plus, half this one. Okay. Anyway, so let's see. So if you look at this program, is exactly similar to the previous one. So I created a new function. You have this function. It's called periodic interrupts. It's channel 3, timer 2. This way. If you look at this code and compare it to the previous code, is exactly same thing. Is exactly the same code, but I just added something. So let's see what you added here. So this one, it was in the previous one. This one was in the previous program. You need to enable. All what I did, I just added this part. That's it. So all what I did, I just added this part. What did you add? Number one, I need to enable. I need to enable interrupts of channel 3, and also I have NVIC. That's it. So this is similar to what we did before. In order to do enable, you have to do 2 things for enable. It's one at NVIC and the one at this one. And I put 15 because this is the interrupt number, okay, as we did before. Anyway, so that's the only modification I did on the previous program. Okay, and then after that, all what you have to do, guys, is that after that, all what I did, just call this function. Once you call this function, you are going to have periodic interrupts. Every what? Every 1 plus. So here you have interrupts every 1 plus ARR millisecond. Okay, millisecond, because every count is 1 millisecond. Is that okay? So I'm going to have periodic interrupts every 1 plus ARR. Okay. So here in this case, I selected ARR to be 1000. That means I'm going to trigger interrupts every 1 second. Every 1 second, 1 interrupt. Every 1 second, 1 interrupt. Is that okay? So, and also, so again, this program is similar to the previous program. So I like to teach it this way. Have a simple case, and then I complicate it. So this program is similar to the previous program. All what I did, I just added this part, just for interrupts, okay? And once you do that, you are going to have periodic interrupts. Also, you have to put the handler here. Okay? As I told you, so there are 4 sources of interrupts. They are going to call the same handler, as I said before, okay? I want to make sure this interrupt is coming from channel 3. So that's exactly what I did. So if you see here, guys, how can you do this one? I need to look at the flag bit of channel 3. So yeah, so what I did here, guys, I'm gonna check the flag bit of channel 3. I'm gonna see if it is 1 or not. Okay, so here what I did, I just want to make sure this interrupt is coming from channel 3. It's not coming from channel 0. It's not coming from 1. It's not coming from 2. It's not coming from timer overflow. You know what I'm saying? So I need to check this bit. Anyway, so I'm going to check this bit. Also, you have to clear it by writing 0. So you have to clear the bit. If you, this is, when you raise your hand, software has to clear it. Okay? By this, and then write whatever you want to write. So here I wrote, I flip the LED. You can write whatever you want to write here. Okay, so now you have function. This function is going to be called every 1 plus ARR millisecond. Any questions? Okay, guys. Okay, so okay, I think that's enough for today. Let's continue next time. Okay.